思っている人も多いでしょう。ひょっとしたらそんな日が来るかもしれない。
Crops and climate change. As the world's population continues to grow, so does its need for food. Yet the problem of ensuring an adequate food supply is being made even worse by the global warming being caused by greenhouse gases, which is resulting in destructive climatic changes on a planetary scale. In particular, droughts are becoming more common, as increasing temperatures lead to the dehydration of formerly productive agricultural areas and the increasing evaporation of water from lakes and reservoirs. This is disrupting the production of cereals and other staple food crops. As a result, many experts are foretelling a greater frequency of food shortages in the future, and even now, some areas are on the brink of famine. In this context, a number of competing companies are trying to develop genetically modified crops that will be able to grow in more difficult environments. One of these is Monsanto, the biggest crop biotechnology company in the world, which recently announced that it had created the prototype of a new drought-resistant corn able to grow in drier conditions than other kinds of corn. The company claims that the corn can provide a 10% increase in yields in areas of farmland that receive less rainfall. Recently, at a farm show, the new plant and a traditional one were exhibited alongside one another. Neither kind had received any rainfall for the whole summer, and while both had withered to some extent, the new one was a little greener and a little taller. Many farmers in the United States welcome these efforts. For them, irrigation is a major cost. This is because thousands of gallons of expensive water are needed to grow crops or keep pastures green. Other biotechnology companies are also working on creating genetically modified GM crops that will grow on land formerly considered barren. Critics of GM, however, are uneasy at the way these companies are jumping at the opportunity presented by the world's precarious food supply. They suspect a conspiracy in which, in the name of helping to feed the hungry, the companies plan to dominate third world agriculture. Because GM crops are patented, every time farmers use the seeds, they must pay a fee to the company which has developed them. These critics accuse the companies of magnifying the ability of their products to grow in dry conditions in order to have them accepted. There are, however, alternatives to developing new plants in the laboratory. Some drought-resistant crops have already been developed using traditional breeding techniques. The Alliance for a Green Revolution in Africa, whose mission is to provide more efficient crops for that continent, has said that it will avoid GM in its work. Still, the gravity of the world's food situation continues to grow. With so much at stake, it remains to be seen whether people will really continue to be able to resist the temptations of GM technology.
動物を飼っている人の中には、ペットと話せたらいいのにな。
The debate over animal language. Ever since antiquity, many people have been captivated by the fantasy of learning how to talk to animals. But can animals use language? They can clearly communicate in a simple way. For example, dogs learn how to recognize and heed certain commands. Does this communicative ability, though, amount to having a language? In fact, this issue has caused great controversy among biologists, many of whom are reluctant to attribute language to animals. Animals, they argue, are incapable of understanding something as complex and intricate as a language. Other specialists, though, say we cannot write off animal abilities in this way, and that the assertion that animals do not have language is nothing more than human arrogance. Indeed, some scientists have devoted years to compiling evidence that animals can learn human languages. Experiments in which animals are taught human languages have attracted the most publicity. Probably the most famous example is Coco, an adorable female gorilla who worked with scientist Penny Patterson for 28 years. Coco's vocal apparatus was too clumsy for the accurate imitation of human sounds, and so she used American Sign Language instead. According to Patterson, Coco learned over 2,000 English words, which she could use to communicate her wishes and feelings. Another famous example is Alex, a parrot, who learned to speak 150 words, and according to animal psychologist Irene Pepperberg, also used them to communicate thoughts and feelings. These seem to demonstrate that there are no absolute barriers to the acquisition of human language by animals. A famous critique of the assertion that animals can learn languages, however, was made by animal scientist Herbert Terrace, using his own work with a chimpanzee. He argued that scientists confuse animal behavior with language. They distort the evidence by interpreting behavior on the analogy of human language, disregarding more economical explanations. Closer inspection of the alleged use of language, however, suggests that animals simply learn that using a certain sign leads to a certain reward. There is nothing informative about the behavior, and it does not express concepts like human language. Terrace's argument was widely influential and led many animal scientists to become much more cautious in their claims about animal abilities. But how about looking at things the other way around? Instead of trying to teach human language to animals, why not try to learn to understand animal languages? In fact, many scientists have also been studying this question for years. According to one group, sea lions emit different sounds in order to communicate ideas to their fellows. Another famous series of studies argues that prairie dogs employ a sophisticated series of sounds not only to warn of approaching humans, but also to describe what they are like. Here, too, there is disagreement because such claims are so difficult to prove. If true, though, then perhaps one day we may indeed be able to chat pleasantly with our pet dogs just by learning to bark.
気の向くままに飛び回っているように見える蜂ですが、実は
Finding the bee line. Bees are among the most fascinating creatures in nature, and since ancient times, human thinkers have often praised their admirable qualities. Their dedication to the community and their energetic and cooperative behavior in gathering nectar and conveying it back to the hive have long been held up as models for human behavior. Modern science, moreover, has discovered many other talents in bees, apart from their famous diligence. They are able to remember accurately the locations of flowers, and to communicate this information to each other by dancing. Moreover, they are vital to human welfare because of the essential role they play in the pollination of plants. Now, however, a team of scientists in London has discovered that bees have yet another talent which may one day prove useful to human beings. We are all familiar with the buzzing of bees in summer as they roam, apparently impulsively, from flower to flower in their ceaseless quest for nectar. Surprisingly, though, It turns out that bees are actually highly expert in calculating the most efficient way to navigate between the numerous flowers they visit. When a number of different plants and trees exist, there are, of course, myriad possible routes that can be taken. It is crucial for bees to find the shortest one in order not to exhaust their limited energy before returning to the hive. How exactly they do this, though, remains a riddle. The existence of this ability was proved by an experiment carried out by Mathieu Lihoho and other researchers at the University of London. They arranged 6 artificial flowers in a pattern for the bees to visit. They carefully complicated the pattern so that the best route was not simply to cruise in a straightforward way from one flower to the next. Altogether, 720 different routes were possible, but the bees were able to pinpoint and remember the roundabout but most efficient route after only 80 trips. Armed with this asset, bees are able to maneuver between flowers in a way that consumes the minimum energy needed to visit all of them. Moreover, bees do this with brains 100,000 times smaller than human ones. Exactly how the bees do this remains a subject for ongoing research. The most likely explanation is that at first they fly in a random way. Then, on each subsequent trip, they measure the route against the earlier ones, and if it is shorter, they adopt it. In this way, they refine and abbreviate the route through a process of continuous amendment. In so doing, they are able to progressively cut back on energy use. Human beings with their bigger brains can map out a route beforehand using a chart or some other blueprint. But in cases where routes continually change, such as in communication networks or busy transport networks, utilizing a skill like that of the bees could be an attractive option.
多くの動植物がシロアリの恩恵を受けていることを知っています。
Masters of the Savannah. Africa's grasslands, known as savannas, support many magnificent creatures, such as lions, elephants, and giraffes. These large animals are commonly thought to play the most important roles in the savanna ecosystem. Recent research, though, suggests an animal's size does not always indicate its ecological impact. Scientists at Harvard University and the University of Florida have found strong evidence that it is actually the termite, an insect similar to an ant, that has the most influence. The scientists became aware of this while studying the population distribution of lizards in the savanna of central Kenya. They noticed unusually large numbers of lizards living near termite mounds, the huge nests built by termites. Further study revealed many other animals and plants are also at their highest density near the mounds. According to the scientists, termites enrich the soil by converting dead wood and vegetation into nutrients. Their activity also loosens the soil, improving its ability to absorb water. This creates a particularly suitable environment for wildlife and plants to thrive. What most amazed the scientists was the influence the termites had on the overall health of the savanna. Satellite photographs show their mounds are spread evenly across the grassland, like squares on a chessboard. The scientists believe this layout brings the ecosystem to its maximum possible productivity. This discovery may be especially important for conservationists restoring degraded ecosystems, such as coral reefs. Corals laid out in a similar fashion might lead to increased productivity in those ecosystems as well.